Okay, so welcome everybody to this low-code solutions for marketing analytics webinar. Before we start with the presentation, I would like to tell you a few news. So the presentation is going to be 45 minutes. We have the last 15 minutes for question and answers. Of course, you can always ask questions in the Q&A. Ali is going to be there to answer together with Roberto. The session is recorded and will be available on YouTube. The slides will also be available and they will be on the KNIME forum. The example workflows are also all available on the KNIME Hub. So this, I guess, answers already most of the questions that are going to be asked. Okay, so let's start. I'm here to present this webinar together with Francisco Villarroel and Ali Asghar Marvi. Francisco is an assistant professor of marketing at Luis Guido Carli University. His research is around unstructured data like online reviews, social media content, image mining, and similar content for marketing insights. He was also awarded the title of KNIME Contributor of the Month in April 2022. I am the head of data science evangelism at KNIME. I have spent 25 plus years in applied AI, predictive analytics, data science, machine learning, however you want to call it, in a broad range of industries like IoT, customer intelligence, healthcare, financial services, cybersecurity, and more. Ali is a working student at KNIME. He has worked on a diverse set of applications with KNIME Analytics platform. He's currently a student for a master program with specialization in data science at the University of Constance. So after the introductions, then let's start with the presentation. Francisco?
Thank you, Rosaria, for the introduction. So this presentation, as Rosaria mentioned, is about marketing analytics, right? And one of the reasons of why we do this presentation and we do this collaboration is that actually most of marketing departments within organizations have some issues at measuring quantitatively the impact of marketing efforts. So this means that marketers need somehow new solutions, easy to implement, to measure the quantitative value of their actions in terms of maybe content creation in social media, pricing, promotion solutions, and the impact on churn. And this is somehow part of the motivation of our work. Can go to the next slide. Another motivation is also, despite we've been talking about artificial intelligence and big data somehow for more than 20 years or so, much more in the last 10 years, only a few companies actually are doing something related to with analytics, artificial intelligence, and big data, right? So there are still opportunities for them to implement activities, and that somehow was another motivations for us. You can go to the next slide. So what marketing analytics is, and the definition somehow from marketing, from a marketing point of view, is that it consists on the methods for measuring, analyzing, predicting, and managing performance with the purpose of maximizing effectiveness and return on investment. I really like this figure as it represents what we do somehow with this project and what I understand also about marketing analytics. So we have different types of data. That's what we are seeing nowadays in the industry: text, images, audio, video. And as new types of data come, we need analytics and new methods to analyze this data. How do we implement those analyses in marketing is mainly with solutions for customer relationship management, personalization, marketing mix, and privacy and security. And that, of course, has an impact on how we teach, let's say, our students in marketing school or business schools, and how companies also use this data. Next slide, please. In today's presentation, we'll cover 4 main applications we have developed. One, extracting knowledge from the web, and mainly an application about search engine optimization, very popular marketing topic. Second one, for image mining, very relevant today in a world which is more visual than textual. Customer intelligence, mainly related with estimating churn and segmentations of consumers. And finally, another very popular topic nowadays in marketing, which is customer experience and sentiment analysis. The project is also part of a research output that we had a collaboration here with KNIME, Roberto Cadilli from KNIME, Karin Melcher, and also Ali, in which we developed this somehow repository for marketing analytic projects in the KNIME Hub, right? And you can find the paper in this link, and it has somehow all the story about it, you know, the practical relevance of marketing analytics, the theory behind marketing analytics, and of course the applications that we develop. For the newbies somehow, or the people who is just interested in trying KNIME, this is more or less how it works. So I usually tell this story that I had a professor in my university back then with he will say that if you know how to click and how to read, or how to read and how to click, you should be able to use KNIME, right? And that's the idea somehow on low code and democratizing data science, right? That we want to make data science a little bit easier in the process part. Data science is not easy, and it's we don't need to make it even harder by writing and typing all this code and making it, let's say, difficult. We need to improve the accessibility to people to it, right? And I believe that KNIME is a good solution in the sense that it makes this process simple and have people, students, and educators to have a faster learning curve. Next slide. Well, here you can find, let's say, in the KNIME Hub, the projects that we have developed, right? Each project has a description. We have projects in the areas that we currently describe. So next slide, please. Well, here is more details about it, right? Each of the projects, and within each folder, you will find everything related to the project, including the workflow and a brief description about it. Next slide. So now we start with the solutions. We have Ali, who is going to explain the first solution that we're going to talk about today, which is kind of collecting data and using data for search engine optimization. Thank you, Ali.
I'm going to explain it. Okay. It's okay. We have optimized. Okay, Ali comes at the end. Okay, so let's start to see some of those marketing solutions. So we start with extracting knowledge from the web. As we all know, the web is the place to find information. Information means information about products, customers, competitors, web pages. So let's focus on the web pages. Can we collect information about web pages from, for example, Google Analytics? And also going in the opposite direction, how can we make our web page stand out for search engines? And how can we make it easy to find by the public? Okay, so the first question, let's start with the first question. That's the easy question. Can we collect information about web pages from Google Analytics? That's easy to answer. Of course, it's possible. You just need 3 nodes: the Google Authentication node, the Google Analytics connection, and the Google Analytics query node. The Google Authentication node, well, allows you to get authorized to perform the Google Analytics query. The Google Analytics connection node allows you to connect to Google Analytics, and then the Google Analytics query actually creates and runs the query on Google Analytics. The output of the Google Analytics query contains all the results from the query, from the query running on the selected domains. And then you can see that with these 3 nodes, you can explore all the measures that Google Analytics can offer you. So the number of views, the number of users, the number of new users, and all the other similar metrics provided by Google Analytics. The blog post that describes this approach can be found here. Notice that on top of each one of these solutions, we have a few links. Usually there is a link for the publication, so either a blog post, or if it's coming, there is a TBA, and then a link to the workflow. Here we don't have the link to the workflow, also because you need a Google authentication. But in the other slides, we are going to have a link to the workflow as well. The second question was, how can we make our web page stand out for search engines? And this is a problem of search engine optimization, or SEO. Search engines like Google, they crawl the web page content and then they rank the web pages according to the keywords they contain. The keywords can be used alone, that was used in the past, but since many years already, keywords are considered together, either conceptually or semantically related. The web pages that include most meaningful keywords, they rank highest in the search engine results. And that's what we want for our own web page. So how can I find which keywords are the most meaningful keywords to have in my web page? And that was the workflow developed actually by Ali. So if you have questions about this workflow, please write them in the chat, in the Q&A for Ali. The workflow is a bit more complicated than the 3 nodes to access Google Analytics I've shown before, but the sequence logic is similar. So first, we run the query and we collect the results from the search engine. Then we scrape the content of the website provided by the results of the search engine. We then investigate, we look for keywords in the text that we have scraped, and then we visualize the keywords that we have found. We can visualize the keywords either alone, for example, in this word cloud, or together in pairs of occurring keywords, for example, with this graph, or using the heaviest keywords describing the topic that we have identified in the text via the latent Dirichlet allocation algorithm. This workflow is available on the KNIME Hub, again here, and we have a blog post, the link for the blog post is here. It was built on an old article by Paul Shapiro published in 2015. Okay, so let's describe now the image mining applications, Francisco.
Thank you, Rosaria. So for image mining, we have developed 2 workflows, one for the feature exploration and the second one for image classification. Next slide, please. Why images? Why we wanted to develop a workflow on images for marketers, right? And nowadays, marketers, or especially digital marketers, need to deal a lot with visual content, images and video. About 74% of the content generated by consumers and also by firms is images, right? So we are facing this trade-off on images generated by users, right, and images generated by firms. With this workflow, we wanted to somehow stimulate and facilitate the execution of image mining tasks for high volumes of images. The first workflow that we developed, it's very nice. I really like it. Roberto developed this workflow, and you need really just 3 things to make it work. You need the workflow, you need to have a Google Cloud Vision account, which you need to enter. Let's say you have to pay for it, and until 1,000 images, it's free, but more than analysis on more images, you have to pay. So you need that account. And the last thing you need is also having Anaconda installed in your laptop. Having those 3 things working, this workflow runs smoothly. And what it can do is analyze a large, let's say, file of folder with images in your laptop. That's where you see the number 1 there in that workflow. It just reads, many images that you might have stored in a folder in your laptop or somewhere, and connects, let's say, to the Google Cloud Vision through their API. That's where you see the post request, and that's the first step. On the second step, it collects, let's say, the analysis from Google Cloud Vision API in terms of 2 main things. Number 2, it focuses on the colors of the image, and it extracts all the colors that are present in the image, and especially the most dominant ones. And in number 3, it collects also the objects that are present on that image, which can be thousands of them, right? Which can be a car, could be a person, could be a cat, etc. So that's this workflow, and there you see the link to it. Next one. This is a little example on what it does. So imagine we have this type of image, and what can we see there, right? It's a dog and maybe a hat, but what else? If we are running an analysis, imagine in thousands or millions of images, right? And if we run somehow this image through our workflow, the first thing that we might unveil is dominant colors, right? And we see right there a histogram of what's the dominance of each color in terms of percentage in the image, right? And we get all those values in a single, in separate cells. So let's say for analysis, this is great. It really helps people who is running, let's say, any type of analysis concerning colors. What else can we see? Next part, objects, right? Labels. And we see here that this image, I don't know, concerns a dog. It has a party hat. There are plants there, etc. Right? And all those things are collected, let's say, instantly. So it really saves so much time if you are interested in running image analysis at scale. And of course, this is just one example, but the problem, as I have repeated many times, become cumbersome when we have too many images. Next one. Sometimes, you know, Google Cloud Vision, Amazon Recognition, or any of these services might not give us automatically what we need, right? Maybe we need a category that has not been analyzed by these automatic tools, you know, and we need to, let's say, develop our own classifier. And in that case, how do we do it? Of course, KNIME also offers the capabilities to develop, let's say, in this case, a deep learning model to identify or classify, in this case, identify objects in an image, right? So we created this workflow for image classification or object detection, in this case, to identify if the image contains a cat or a dog, right? And it has also, same as I said before, some components that you can visualize. At the bottom, we have just data preparation, which allows us to pre-process image, kind of make them in the same size, the same pixel number, prepare to standardize somehow our image data. In the part at the top, includes our network architecture that we have to build, deep learning architecture with all the layers that are needed for the process. In part 3, we are able to, with the Conda environment propagator, which is a great source, we connect, let's say, to Python, to the Python environment, and we are able to use a Keras network learner to somehow develop a predictive model to identify cats and dogs in an image. Later on, within that same block, number 3, we can assess the accuracy, precision, and recall or classification. Right, so that's the training part, and of course we accompany that training part with deployment. Right, we have a separate workflow in which a user that is interested in automating this process for new data can also do it and apply the deep learning, let's say, algorithm that was developed. Right, next slide. So, like in this case, for example, we had the image classifier is identifying cats and dogs, right, and that was the task that was kind of related to. And in the next slide, it's also very sensitive to the type of information that we enter to the classifier and to the analysis, right? So in this case, for example, it can also make mistakes. In the image at the top, you see maybe that cat was classified as a dog. Why? One of the reasons might be that we fed the classifier with too many images that in which white dogs were, let's say, occurring, and it classified that cat as a dog. Right, and yeah, and that could be somehow part of the issues with the classification, which is always going to be as good as the data that you are using, right, to create a classifier. Good. I leave you back with Rosaria.
Okay, so the next applications is the old classic applications about customers. Everybody has customers, and this is the classic of the classics, churn prediction. How can we discover which customers are at risk of churning? So which customers are at risk of canceling the contract? The other classic task is customer segmentation. How can we separate our customers into groups so that we can target them better with more interesting offers or more interesting information? So those are the two evergreen tasks that people still work on: churn prediction and customer segmentation. As I said, churn is still a big problem. I've been working in churn for a long time, but it's still a big problem. Music Watch reported that only 48% of those who tried Apple Music were still using the service 2 months after it was launched. So as you see, a big churn problem. At the same way, for mobile apps, it is reported that across all categories, 75% of all app users churn within 90 days. So churn prediction is still a big problem, even more so in a more digitalized business environment. So the solution that we provided to predict the risk of churn for a customer was based on a classic machine learning algorithm. In this case, it was a random forest algorithm. Again, we had two workflows. One was to train the model, the random forest, and the other one was to deploy the model for real life data. Okay, let's have a look at the training. Again, this is similar to what we have seen before. Here we acquired the data. Here we perform some data transformation with the yellow nodes to prepare them to feed the random forest. Here the preparation, the separation between training set and test set in this case is done by a cross-validation loop, here the loop, while before it was done via a partitioning node, if you remember the image dog versus cat classification. And finally, so we train the random forest node via the random forest algorithm via the random forest learner node, and then we evaluate on the test set this time the performance of the random forest model on the test set data. On the right, we have the same thing, but this time we don't train the model anymore. We just read the model, we apply to the new data during the production phase, and then we produce some kind of visualization that tells us how high the risk of these latest customers of churning is. In this case, we have 5 customers that they arrived in the last 1 hour. You can see that after the analysis, the probability of churning of those customers is for 4 of them relatively not worrisome. I mean, they have a high probability of not churning, but 1 of them has a high probability of churning. You can see from the bar chart, you can move into the tile view down here where you can see the details of each one of these customers reproduced in the bar chart. So as you can see here, this customer has a probability of churning of 0.8. So this is a classic churn prediction solution. Once you identify those customers with a high probability of churning, then that triggers some kind of retention program strategy, something that allows to talk to these people who might want to churn. The second problem was the customer segmentation. We want to separate our customers in useful groups so that we can target them with more interesting offers or with more interesting information. Sometimes you know the rules of the business already, so you already know how you want to separate your customers in groups. Then it's easy. I mean, you just write a few data transformation rules via a rule engine and it's done. But sometimes you either don't know or you just want to experiment something new to see if you find groups that you didn't know they exist. So in this case, we use a clustering procedure. Here is a k-means. So another classic clustering procedure. You can use another possible clustering method. This generates this very simple workflow, and we have a visualization here in this component that is named cluster Vs. We can make it a bit more complicated by expanding this visualization, for example, looping through all the clusters and then visualizing the cluster one by one. Again, the workflows are available on the KNIME Hub here, and the KNIME blog is, the blog post is still to be published, is still to appear. We can show here just a few of the prototypes of the clusters. You can see that in this scatter plot of customer service calls and voicemail messages, you can find the prototypes of the clusters of the people using the voice message, the voicemail, and of the complainers. They have an average of at least 2 calls to the customer service. In this other scatter plot, you can find, for example, here you have the minutes spent in nightly call, and here is the minutes spent in daily calls. So up here you can find all the groups with the nightly callers, and here you can find all the groups with the daily callers. Again, once you identify these new clusters of customers, then you can decide how you want to proceed, you know, given their features. Okay, customer experience, Francisco.
Thank you. So for customer experience, we developed two workflows, and the two of them are somehow very I know timely right nowadays. One, analyzing topics relevant to marketing from customer reviews, and the second one, measuring sentiment from, let's say, any type of textual data. Next one. So why customer experience? Definitely, this is something that most of companies, especially service organizations, will be interested. This has been defined their #1 priority according to the largest customer chief marketing officer survey. So most of companies are worried about this. And what can we determine from customer experience, and what managers would like to see about it? Identify, of course, touch points, you know, that relate with the customer. Like, I don't know, when you are, let's say, booking a flight, you know, the process that relates to, let's say, passing immigration. That might be, there might be an issue there concerning your flight, which of course you don't have control for it, but at least you want to know what are the things that are having an impact in your customers. You can also learn things about context, like what type of contexts are affecting customer experience. Let's say in a metro station, is it the same to be in a metro that is entirely crowded, or is it let's say different from when you are entirely there empty? When is better maybe to send a promotion to your customers? And finally, emotions, right? You also want to learn emotions about what they are experiencing. In the context, let's say you identify fear. Fear many times might be considered a negative emotion, but it might not actually if we're considering a service that involves, let's say, adventure parks, right? And that's all that information can be extracted from reviews data. So that leads us to the next slide, which is the workflow that we developed. We created a workflow to extract customer experience, somehow topics from online reviews. And the workflow is developed in 4 stages. It uses customer experience data from TripAdvisor's 2 hotels. In the first block that we see there, we just prepare data and read text data. We, let's say, remove stop words like de, to, remove also inflections from words. We created bigrams, which are also important concepts that might be in our data, like for example, frontline employee, or like reception staff, you know, which are pairs of words that we need to consider somehow in our model. They're not independent, but they are related. And then we can, let's say, use this pre-processed, somehow clean text data to identify what might be the number of optimal topics in our data, what might be kind of the optimal number of topics, areas that we can find here, right? And in #2, we have identified this process in 2 steps, right? First, identify kind of a wide range of topics, and then identifying a narrower one, which is gonna tell us, okay, you should identify or look for a solution that goes kind of between 5 and 7 topics somehow, right? And search there, right? And then in stage 3, we implement the topic model algorithm with this topic extraction, parallel LDA, and we are able to identify what actually are these hidden topics in our data from the reviews, right? And we create a visualization out of there. That's where you see topic view. And in point #4, we also assess their importance. You know, which of these topics is more predictive of customer satisfaction or the star rating. We can do that internally with KNIME, with the linear regression learner, or if we want to do some more advanced statistics, we can switch to R, right? And that's why we have this table to R node, which allows us to perform an ordinal logit regression, which is somehow a little bit more sophisticated, let's say, analysis. our data. Good. So next slide. That's the visualization. So which topics are more relevant in this case for each of the hotels. A visualization that allows us to compare two hotels in terms of the same topics and which one somehow has a higher probability to occur in our data. Next slide. And that's it. That's the part of topic models. I leave you now with Rosaria for sentiment analysis.
Okay, so another important part of customer experience is sentiment analysis. Again, digging up into review texts, and this times we want to automatically understand if a customer is upset, is negative about whatever it is, our product, or if actually the customer is saying something nice and maybe we can use it as a testimonial for our product. For example, in these two reviews here, the first one is clearly positive, the second one is clearly negative. So that's what we want to find out by reading the text automatically, of course, for tons of reviews. There are four main strategies that we have tried for sentiment analysis. The first strategy is a lexicon-based strategy. So the lexicon-based strategy uses dictionaries and grammar rules to understand the sentiment. It seems the easiest strategy because everybody knows what a dictionary and a grammar is, but actually it's not that simple. You need to have a bit of a linguistic experience to be able to program a lexicon-based sentiment analysis. That's because a sentence like "I had a very bad experience" is easy to classify, but a sentence like "I didn't say that I don't like those shoes" might be a bit more complicated. Another strategy is based on machine learning algorithms. Again, in this case, we have a corpus of labeled sentiment for sentences, for reviews, and then we use an application of workflow to train the machine learning model to recognize the negative, the neutral, and the positive sentences, and then we use another application to deploy the machine learning model in an exactly similar way to what we have done before for the churn prediction application. We have the core machine learning algorithms could be many. I mean, we have decision trees and other tree-based ensemble algorithms. We have support vector machine, and that's what we have used in our examples. We have regressions. We have a lot of those algorithms. Of course, the performances depend on the algorithm that we have selected and also on the parameters, how well we have set the parameters of the algorithm. Another strategy goes into the deep learning direction, and it uses a neural network with a long short-term memory layer. The long short-term memory units allow us to exploit the sequential character of text, the fact that some words can only come after some other words. This architecture then has the added benefit of incorporating grammars inside the analysis of the text. For example, I don't need to code a special rule for negations. The longer the input of the past words or characters, the more complex is the grammar structure that we can introduce. The disadvantage of the neural networks with the long short-term memories is actually the training time. Those are not simple networks, and it might take a very long time to train them to a satisfactory level. Another approach that we have used is the BERT approach. That's the new one, again, in the deep learning direction. BERT are Google pre-trained neural transformers. The advantage is that they are pre-trained. They are pre-trained on a lot of data made available to Google. However, the disadvantage is that they reside somewhere else externally, and so they might not fit exactly what your task is. We implemented all those strategies. We got the best accuracy with the BERT algorithm, but of course it depends also on our expertise. For example, we don't have enough linguistic knowledge to satisfactorily program a lexicon-based model. Let's see what this actually means in practice. I'm going to skip through all the workflows. So for example, let's take these two sentences, right? They are very similar. One is slightly more negative than the other one. So let's see what happens to those in a deployment situation, in a production environment. So let's see how the models have classified these two sentences. So let's take the lexicon-based model. The lexicon-based model is an optimistic model because it finds that many of these sentences are positive. There is a lot of green. So those are, I'm analyzing the tweets about an airline. These tweets, they move from the 10th of, so for a full week of time. I have transformed the word cloud into a sentence cloud so that the whole sentence is reported in the word cloud. So the lexicon-based model about these two sentences classifies them as positive, both of them. And it's in general a more optimistic model. It's working okay, but probably due to our linguistic lack of knowledge. Let's go into the machine learning based algorithm, the support vector machine. This one is working slightly better. You can see that the bias towards the pessimistic and the negative sentences is a bit higher, which is actually true for the tweets that were coming in. And our two sentences were classified, once as negative, the more negative one, and one as neutral. So we are getting closer. If we move into the deep learning, again, we see more positive sentences, and our two sentences are still classified, one as negative and one as neutral. And then finally, for BERT, we are going to see again many more negative sentences, which, as I said, it's probably the truth, and our two sentences have been correctly classified as negative. So as you see, we have implemented all four approaches with different results for many reasons. And as usual, the results that you obtain is always a compromise between how much you know, your experience, how much time you invest into optimizing the algorithm and training it, and how much, let's say, how much faster you want the algorithm to be and its accuracy. Okay, so these applications have been developed also by Roberto and Catherine, and so please, if you have questions, write them in the chat. And now to conclude, we have a little exercise for you, and Ali is going to explain you the exercise.
Thank you, Rosaria. So hello, everyone. As part of this webinar, we have a small exercise for you. It is the extension of the existing machine learning-based sentiment analysis workflow that you saw earlier. This is the part where you have to fill. So next slide, please. So your task here is to try different machine learning models, try to optimize them, and measure its execution time. So the goal is to check which model with what parameters gave a better accuracy in the least possible execution time. So please do share your findings in this discussion forum thread on this link, and happy learning. Over to you, Rosaria.
Ali, do we have any questions from the audience?
I can answer. So yeah. Thank you for your presentation. It was very interesting, and thank you also to our attendees. So there was a question by Vijay who asked about the workflow that implements Google Cloud Vision API, and this question was connected to the label. So using this web service has the advantage, as Francisco already explained, you can identify labels in image. So there is obviously a large collection of labels that Google implements, but of course, there's a black box, right? So we have a service. We don't know exactly how this service, what is exactly behind that. We can also not modify anything. We get a result. It is usually very interesting, and it gives us a lot of insight, but there is not a freedom to change or to add additional labels. And that's why the second workflow where we build our own model can be especially under certain circumstances a better option, right? Because maybe we want to have a specialized task, and you have to consider that those labels are very general, what Google will return. But if you imagine you're working with an image from a manufacturing company, right, where you have like rotors or very specific machines, maybe that is not the right way to proceed using such a generic identification of labels, and you may want to build your own solution. Yeah, so that's to answer Vijay's question. I hope I did. Otherwise, feel free to ask for more.
Okay, so any other question? There is a question about how to use recommendation systems in KNIME. I can answer that. So there are two nodes to use to train a recommendation system. One is the a priori algorithm. The name is a priori, I don't remember, node. So this basically takes as input a card aligned with a data row full of products, of product labels, and then it performs a statistical association between the most frequently items that have been found together in cards in the data set. The other one is the collaborative filtering node. This applies only onto Spark platforms, and this one also identifies users with a similar behavior that have been that have an index of similarities very high to each other. So remember these two nodes, the a priori, now I don't remember the name of the node, and the other one is the collaborative filtering node if you're working on Spark. Okay, other questions?
Yes, we do have one question. So I think it's more of a query than the question. So it's like, it's observed in NLP workflows with 20K plus features, words that some of the learner nodes take a lot of time for execution, especially SVM and decision tree learners. Will changes in KNIME.ini solve the problem?
Okay, so yeah, that's a complicated question. So the SVM algorithm is a bit slow. It's the nature of the algorithm, so it takes a bit of time. Of course, you can increase the memory that you allow KNIME Analytics platform to use, and that can be changed in the -xmx in the KNIME.ini file. This could be one. Of course, you can pre-process the data, for example, to eliminate those columns that are empty or they are constant, or we have a bunch of nodes and there is a full blog post about the 10 techniques that you can use to reduce the input dimensionality of the data set. So there are a few things that you can use to reduce the size of the training set. But yeah, the support vector machine is a bit slow. I mean, the same thing maybe is not true for, so it depends. For example, it's not true for the gradient boosted trees or other algorithm for the nature of the algorithm. Yeah, of course, and especially when you talk about words, you might want to use only the keywords. For example, Francisco, correct me if I'm wrong, but I think in the topic detection workflow, the one where you were searching for the topics or in the reviews of the hotels, I think you reduced the number of keywords to the top, I don't remember how many frequent keywords. Is that correct?
Yes, that's correct. That's very good advice as well. Reducing your, let's say, feature space, right? Reducing the amount of words that you are using to train the model. SVM is very slow, and it's gonna be even slower if you have really a huge feature space, like the feature space, so many words that you're using as predictors. So pre-processing is gonna help you there, like removing stop words maybe, or removing numbers, inflections, bringing everything to lowercase, synonyms, all those type of things will make your execution faster.
I hope that answered your question, Mohammed. So we have one more, and it's an interesting one. So Rosaria, I think it's for you. What are the parameters before conducting the model is good enough to work across all problems? Is it model accuracy or ROC curve?
Yeah, there are books written on this topic. Yeah. So when do we stop? In theory, you never stop because it's never good enough. So there is a moment when you decide that your accuracy or your ROC curve is good enough, also considering the time that you have invested on it. So the booklet by Marit, the one about the scoring models, it contains all of these problematics. So usually we use the model accuracy or better the area under the curve in the ROC curve. But then, of course, it's always a compromise, like I've shown before with the different approaches to the sentiment analysis. Sometimes the time, you have to limit the time. You can't have or maybe you can, but not everybody can wait for 2 days until the neural network is trained or something like that. So it's always a compromise between the time that you want to dedicate and the accuracy or the area under the curve that you want to achieve. So the next question is, are KNIME machine learning models implemented using machine learning Python libraries? Some are wrapped around Python libraries. For example, the neural networks, the deep learning, the nodes are wrapped around the Keras libraries in Python. However, some of those, some machine learning algorithms are native. For example, the decision tree is a native algorithm. It was programmed for KNIME. The support vector machine is another native algorithm. So some of them are wrapped around Python libraries. Some of them are native to KNIME, correct. Okay. So another question is in the sense the model to be productionized. So I guess it's
yeah. I mean, it depends on the use case at times. So maybe at times accuracy is more important, or in some case, another measure is also more important. So it pretty much depends on the use case itself.
And then just an extension metrics and model performance or observability is handled. I'm not sure I'm understanding that. Okay. What is the basis for the workflows that define the process? Any specific libraries?
I think we have we have documentation for each node that you use. So if you are looking for any associated research papers or any main documentation, then I think you can find that in the description itself.
Okay, I see that Roberto is typing an answer.
Yeah.
Maybe Roberto, you want to say the answer publicly.
No, actually, hello. I was asking for Vijay to please expand on the question because I'm not sure I got the point beside the documentation and what Ali already mentioned. So maybe, Vijay, if you can expand a little bit on what you mean specifically, maybe we can provide either links or an answer already.
So he says, I mean model performance MLOps. So the KNIME Analytics platform doesn't help you much, at least automatically, with the model performance control. So with the check, you can put together a workflow that does that. Sure, you can always do that. I don't know, most people rely on the KNIME server for the productionization of the workflow. So if that was the question, yeah.
I think we have one more question. So it says, how many segments do you recommend to configure in the k-means for segmentation? So who will take that?
Francisco, maybe you want to answer that, or shall I answer that?
Please go ahead, Rosaria.
Okay, so the k-means has to be decided a priori. It's not possible to know what it is a priori. There are some methods, like, for example, the elbow methods or the silhouette coefficient that allow you to define the best k that you can use for your data set. And it's the k that allows you for the best separation of whatever data groups there are in there. But it's not possible to know a priori what the best k is, unless you have some extra information about the data that comes from somewhere else. But besides that, then you need to find an optimization method like the silhouette method or the elbow method. Okay. questions? Okay, if there are no more questions, then I think we can close here.
I think we have more of a development related question. So it asks that behind the workflows, where the workflows are defined nicely for demonstration, what libraries are used? So I think it's more of the source code. And I think KNIME source code is open source and it is available on GitHub. So I think you will be able to find your answer over there.
And as I said, some operations are KNIME native and some operations are wrapped around Python operations, also Python libraries. Yeah. Now, yeah. Okay.
Yes, you will get the recording of the session. I think it will be uploaded on YouTube, I guess. Roberto, can you answer that?
Yeah, you will get the recording, or you are going to get an email after the event, and there are all the links, the recording, the slides, the workflows, everything. It's in there. Okay.
Thank you everyone for attending. Thank you, Rosaria, for the invitation.
Thank you, Francisco, for presenting. Thank you, Ali. Thank you, Roberto, for answering the questions. Thank you, Shantano, for being in the backstage. Okay, thank you and bye.